So we've seen how a linear equation describes a line that can be plotted in terms of x and y coordinates. Let's take a closer look at the line described by our equation.
Note that the line extends to any possible pair of x and y values that can be calculated by the equation, including negative values and 0. The point where the line crosses the x-axis is called the x-intercept, and the point where it crosses the y-axis is called the y-intercept. Now, the x-intercept, the value of y is always 0, and at the y-intercept, the value of x is 0. So to calculate the x-intercept, we just solve the equation for x with a y value of 0. And to calculate the y-intercept, we solve the equation for y with an x value of 0. So our x-intercept, let's call it a, is negative 0.5, and our y-intercept, which we'll call b, is 1. Now the slope of the line is calculated as the change in y divided by the change in x as we move along the line. Now by convention we call the slope m, and because mathematicians love using Greek symbols for things, in this case the Greek letter delta is used to indicate change. We actually calculate the delta by taking 2 points on the line and subtracting the x and y values of the second point from the first point. You could use any 2 points on the line to do this, including the x and y intercepts that we calculated previously. So in this case, the slope is 1 over 0.5. 1 divided by 0.5 is 2. So if we go along 1 unit on the x-axis, then we go up 2 units on the y-axis. Now let's return to our original equation. We usually like to arrange terms in an equation so that the terms with variables come before constants, and we just swap these terms around to tidy that up. Now take a close look and note that the calculation for y is actually the slope multiplied by x plus the y-intercept. Now more generally, this is known as the slope-intercept form of the equation, and it includes all the information necessary to draw the line. We can use the y-intercept, or b, to find the point where x is 0, and we can use the slope to find a second point that is any number of units on the x-axis away from the first point.